So today we are going to start electrostatics, right? So electrostatics is basically a study of charge at rest, right? So which chapter we are going to start? Electrostatic. Electrostatic, right? So this is this chapter is basically all about a study of charge at rest, right? So we can write here it is a study of charge at rest, right? So here one new term is coming, charge, right? So how charges appear on any body, right? So I'm going to ask you one question, right? That is how charge appear on any object, any object. How charge appear on any object, right? So to answer this question, answer of this question is transfer of electron, right? What is the answer of this question? Transfer of electron, right? So now you know electron. These things are already discussed in atomic structure, right? So I'm considering all about electron. What is electron, right? But still I'm going to discuss some basic about this one, right? So one more question: why only transfer of electron is possible? Why transfer of proton is not possible, right? Because see, this is our structure of atom. Neutron, basically atom is made up of three particles, right? First one is electron, second one is proton, and last one is neutron. Neutron, right? Proton is having positive charge, positive, and this one electron is having negative charge, and neutron is neutral. Neutron is neutral, okay? Neutral. Now see, suppose this is your structure of atom, right? Neutron and proton is always inside the nucleus, right? And electron is revolving in different orbit. Suppose these are the orbit of your electron, right? So these are the orbit. In this orbit, electron is revolving. Suppose in first orbit, 2 electron is revolving. So now you can see proton is, where is proton? Proton is inside the nucleus, right? So proton is inside the nucleus, so it is difficult to transfer of proton, right? So that's why only transfer of electron is possible for the charge to appear on a body, right? So see, these are the outermost outermost orbit electron, right? So these electron is able to move from one atom to another atom, right? So suppose I'm going to remove some electron from this atom, right? So initially atom was neutral, right? Now what happened? I removed some electron, right? So due to removal of electron, now number of electron is smaller than number of proton, right? So now bodies becomes positive, right? So now see, due to transfer of electron, bodies become positive, right? Similarly, suppose if I'm going to bring electron to this atom, right? If I bring electron to this atom, so what is going to happen again? Number of electron will be more, right? Compared to proton, right? Yes or no? Yes. So what is going to happen? So now due to electron is having negative charge and the electron is excess, right? So now body becomes negative charge, right? So due to transfer of electron, two type of charge is possible, right? Yes. So now I am going to discuss type of charge. Type of charge, right? So first one is positive charge, okay, and second one is negative charge, okay, negative charge, right? So how positive charge is appear? You know, due to deficiency of electron, right? Due to deficiency of electron, right? And similarly, how negative charge appear? Due to excess of electron, right? Excess of electron, right? So again I am going for revision purpose, right? So what is electrostatics? Electrostatics, it is basically a study of charge at rest, right? And how charge appear on a body due to transfer of electron, right? So transfer of electron is only possible because proton is inside the nucleus, right? That is not able to move. So which one is able to move? Only electron. Electron is able to move, right? So if electron will be excess, right? So then negative charge will appear on the body, right? If deficiency of electron, then positive charge will appear on a body, right? So this way we are able to understand how charge appear on a body, right? So next we are going to discuss some basic property about charge, okay? So some notes we are going to write first, right? Notes, okay? In notes, first I am going to find unit of charge, right? So unit of charge, okay? Unit of charge. Unit of charge is coulomb. Coulomb. This is represented by capital C, okay? And another one is dimension. Dimension of a charge, right? Right. So dimension of a charge, right? So dimension means dimension formula. We are talking about dimension formula, right? So how we are going to find dimension formula? You know, I is equal to Q by T. I is current, right? And Q is charge and T is time. So from here we can write Q is equal to IT, right? And dimension formula of current is A, and for T is time, right? So dimension formula of your charge will be AT, right? Okay. So next we are going to discuss property of charge, right? Property of charge, okay? So property of charge. Properties of charge, right? First point, it is a scalar quantity, okay? It is a scalar quantity, okay? It is a scalar quantity, right? Charge is a scalar quantity, right? Okay. And second point, Second point, it is transferable. It is transferable. Okay, it is transferable. That means charge is. That means it is transferable. That means charge is able to move from one body to another body, right? Okay. And third point, neither be created nor be destroyed, right? Nor be destroyed. Charge on any body, charge on any body is integral multiple of basic unit of charge. Basic unit of charge, right? Okay. So these are the some basic property of charge. Okay. These are the some basic property of charge. So charge on any body is integral multiple of basic unit of charge, right? So suppose Q is the charge on any body, right? So this charge will be equal to NE, right? Where N is integer, where N is integer, okay? Where Q is charge, this Q is charge and N is integer and E is magnitude of charge on one electron, right? Which is equal to 1.6 into 10 to the power minus 90 coulomb, right? So these are the basic property of the charge, right? Okay. So next we are going to discuss method of charging, right? Okay, method of charging. So method of charging, okay. So basically three method of charging, right? So method of charging. Method of charging, okay. So basically how many method of charging is possible? Three, right? Three method of charging is possible. First one is friction, right? Friction is charging by friction, right? Okay, so charging by friction, right? And second one is charging by induction, right? Charging by induction, or we can call it electrostatic induction, right? And last point is conduction, right? Conduction, right? So only these three methods of charging is possible, right? Now we are going to discuss this one by one, okay? So first one is friction, right? Friction. How we can charge the body by friction, right? Okay. How many of you ever feel that when you are start rubbing your comb in hair, right, and bringing it to near to the piece of a piece of a paper, right? So what is happening there? Paper is comb is start attracting the paper, right? Why that one is attracting? Due to some transfer of charges happen between comb and your hair when you are rubbing your comb in your hair, right? So due to that, charges appear there, right? So this method of charging is known as frictional charging, right? Charging by friction, right? And another one is electrostatics induction, right? Induction, right? So what is electrostatic induction? Now we are going to discuss this one, right? Suppose this is a metal sphere, right? This is a metal sphere which is fixed on a insulated stand, right? This is a metal sphere fixed on a insulated stand, right? And now this is initially this one is having no charge, okay? Initially this one is having no charge, right? No charge means positive charge is equal to negative charge, right? No charge means every body charge is existing on any body, right? But net charge is zero here, right? So negative, positive, right? So now this body is neutral, right? Neutral means positive charge is equal to negative charge, right? Suppose now I am going to bring another positive charge object near to this sphere, right? So suppose this is your positive charge object. I am bringing this one near to this sphere, right? So as you know, positive repel each other, right? And positive and negative attract, right? So what is going to happen here? So this is positive, right? So all positive charge will move away from this one, right? That means all positive charge is going to sit another side of a sphere, right? And all negative charges getting attracted by positive, right? That means all negative will come to this side, right? So as I bring this one, so here on this sphere, what is going to happen? Redistribution of charge is going to happen, right? Redistribution of charge means all positive charge will go to that side, come this side, and all negative charge will come to this side, right? So so now see, after redistribution, figure will be like this. After redistribution, figure will be like this. All positive charges this side, right? And all negative charges right? So now you can see initially positive charge and negative charges distributed all over the sphere, right? But now what happened here? All positive charges shifted to another part of a sphere and all negative charges shifted to this side of a sphere, right? Suppose now I am going to connect a wire. I connected this wire and I am going to make it earth. Making earth means what? Making earth means connecting to the ground, right? So I connected a wire on this part of a sphere and this wire is earth, right? Earth means connected to the ground, right? Now what is going to happen? All this positive charge will move into the ground, right? All positive charges move into the ground, right? And negative charge is not going to move. Why? Because negative charge is attracted by positive one, right? But positive is able to move, right, to the ground. So now all positive charges went inside the ground, right? Now suppose I am going to remove this. Suppose I am going to remove this wire, right? So now figure will be like this. Now see, all negative charges went into the ground, right? All positive charges went into the ground, right? So only negative charge is present, right? So again I'm going to remove this one, right? So positive charges went into the ground, right? And now I'm disconnecting this one, right? Disconnecting this one. That means this positive is not present. This positive is went into the ground, right? Only negative is present, right? And so now I'm going to remove this one, and so distribution of, again negative charge will distribute all over the body, right? So again negative charge will distribute in on the entire body, right? So now see, this body is becomes negative charge, right? So this method of charging is known as induction, charging by induction or electrostatics induction, right? And another one is charging by conduction, right? Charging by conduction. Okay, so I hope you are able to understand this one, right? So next we are going to discuss this one, conduction, right? How we can charge a body by conduction, right? Charging by conduction. Okay, now suppose this one is a uncharged body, right? Uncharged body means having no charge, right? Having no charge means positive charge is equal to negative charge, right? So suppose this is your neutral body or uncharged body. Okay, and I am bringing here one positive charge. Suppose this is a positive one, right? This body is having positive charge, right? As I bring this body is in contact with this one, right? Suppose I am bringing this one in contact, right? Now I am bringing this body in contact, right? What is going to happen? See, this one is having positive charge, right? So I am making the figure like this, and this is having positive as well as negative both, right? So here, now see, this is having positive charge, right? So as you know, positive charge will attract negative charge, right? So all negative, here see, negative is present, right? So negative charge will start moving on this one, right? So negative charge, if negative charge will start moving on this one, right? Negative charge will start moving on this one, right? So initially it was having equal number of positive charge as well as negative charge, right? Now what happened? Some negative charges move to this one, right? So now this body is also becomes positive charge, right? Now this body is also becomes positive, right? And this one is already having positive, right? Right. Now, so we can see that due to bringing this charged body in contact with this uncharged body, right? This uncharged body is also getting charged, right? So this method of charging is known as conduction, right? So conduction is somehow we can say that bringing charged body in contact with uncharged body, right? So that method of charging is known as charging by conduction, right? So only these are the method of charging, okay? So this way we are able to charge an object or any body, right? So today I am going to discuss only this much, right? Whatever things I discussed here, everything I will give you in note, okay? No need to worry about that one, right? Okay, so in next class I am going to start Coulomb's law, right? Okay, yeah, before that I have to solve one question, okay? Okay, so I'm going to take one question. That question is also given in your NCERT, right? That one we are going to solve, okay? So first see what is the question, and so I have to write so you are able to find that question in your book, right? That question is basically given in example, right? So example Example 1.2 NCERT. Okay, just read it, just see this question. NCERT example 1.2 NCERT, right? Okay, so what is that question? Okay. Okay. In this question is if 10 to the power 9 electron, right? If 10 to the power 9 electron move out of a body. Okay, I have to write the question. So I'm writing the question first. If 10 to the power 9 electron Okay, so now see the question. In question, if 10 question is if 10 to the power 9 electron, right, move out of the body, right, to another body every second, right? So we can see that this much electron, right, is going out of a body in every second, right? That means in 1 second, how many electron is going out? This much, right? And what we have to find? Time required. We have to find time required, right? Time required to get a total charge 1 coulomb, right? So we have to find total time required to get total charge of 1 coulomb, right? So somehow this question is based on unitary method, right? So I hope you know, all of you know unitary method, right? So first I am going to find how much charge is moving out in 1 second, right? How much charge is this much electron is moving out in 1 second, right? So how much charge is moving out, right? So we can write here charge moves out in 1 second. Charge moves out in 1 second, right? Charge moves out in 1 second is basically equals to Q, right? And that Q is nothing but an E, right? In question, N is given, right? See, N is given. I am writing here given. What is given? N. Number of electron is given 10 to the power 9, right? And E is known to you, right? E is the charge on an electron. This is equal to 1.6 into 10 to the power minus 19. I am writing magnitude only, okay? Because electron is having negative charge, right? But I am taking here positive because I am taking magnitude only, right? Okay. So N is given 10 to the power 9 and E is known to you 1.6 into 10 to the power minus 19 coulomb, right? Okay, 10 to the power minus 19. So if you are going to solve this one, so 1.6 into 10 to the power, what will come? 1.6 into 10 to the power minus 10. Okay, yes or no? Okay, so charge moves out in 1 second is equal to this much coulomb, right? So now we can say this amount of charge is moving out in 1 second, right? So we can write here 1.6 into 10 to the power minus 10 coulomb charge move out in 1 second, right? Charge moves out in 1 second, right? So 1 coulomb charge, right? So 1 coulomb charge moves out in 1 by 1.6 into 10 to the power minus 10 to the power minus 10. Okay, right? So if you are going to solve this one, right, so 1 by 1.6, right, so this one will comes about 0.625, right? 0.625, right, into 10 to the power minus, if I'm going to say this one in upside, it becomes plus, right? So we can write here 10 to the power 10. Okay, this is further written as 6.25 into 10 to the power 9 second. This is your answer, right? So that's all about today's lecture. Okay, so in next lecture we are going to discuss Coulomb's law, right? Coulomb's law. Okay, let's talk.